So in this experiment, we have to discuss about the PN junction diode VI characteristics. In PN junction diode VI characteristics means V means voltage, I means current, V voltage versus current characteristics. What is the aim of this experiment is to draw the VI characteristics of a junction diode and determine the cut-in voltage. Cut-in voltage means that is knee voltage and forward resistance and reverse resistance. This is the aim of this experiment. What are the operators? The operators is first junction diode we want to take. This is the junction diode. Here two terminals are there. One is positive terminal. Which portion is majority? That portion is positive terminal. Here black portion is majority, silver portion is minority. Black acts as a positive terminal, silver acts as a negative terminal. This is the junction diode. Junction diode, power supply, this one is power supply and this one is another power supply is there. Now 220 ohms resistance we have to take. This one is the multimeter. From that multimeter we have to take the 220 volts resistance we have to take. Once you able to see what is the 220 volts resistance, suppose here whether it may be this resistance is 220 or not, you have to check it. Now you able to see how much resistance is there. Now I am switch off. Once you have to see the resistance of the 2.18, that is 220 ohms resistance is there. Clear? Now I have to take the 220 ohms resistance and voltmeter. This is the voltmeter and this one is ammeter. Ammeter, this one is the ammeter. First, what is the formula? Formula is to find out the knee voltage. For a germanium diode, we have to calculate the knee voltage is 0.3 volts. For the silicon diode, what is the knee voltage? Knee voltage is 0.7 volts is the knee voltage. How we have to calculate the resistance? Forward bias resistance delta V by delta I. From the slope we have to find out 1 by slope is equal to forward bias resistance will come. The reverse bias resistance is delta V by delta I. V2 minus V1 is divided by I2 minus I1, which is equal to 1 by slope. This is also we have to calculate it from the slope only. First, to identify the values, first we have to apply the circuit diagram for forward bias and reverse bias. What is the forward bias? Diode positive terminal, you connected to the positive terminal of the battery. Diode negative terminal, you have to connect it to the negative terminal of the battery. Such type of connection we call it as a forward bias connection. Now you have to see here. So this is the power supply positive. Power supply positive, I have to given to the resistance one end. The resistance next end we have to give to the milliammeter positive. Milliammeter negative I am giving to the diode positive. So diode negative I am connecting to the ground. Clear? So now if voltmeter negative I am connecting to the ground. Power supply negative also I am connecting to the ground based on the diagram. Power supply voltmeter negative, power supply negative, diode negative I am connecting into the ground. These are the ground terminals. Ground terminals. Clear? So once you have to take here in the ground terminal, what we have to do? The reverse bias also same. Once you have to interchange this diode negative to positive, positive to negative, then it will goes to the reverse bias. How we have to calculate the observations once you have to see. Switch on the power supply. Now I am switch on the power supply. First input voltage you have to measure. Where I am connecting the input voltage, wherever we are connecting the power supply positive, there I am connecting the input voltage. Now you have to set it. First 0.1 you have to apply, serial number 1. The input voltage is 0.1. Now you able to see the output voltage. Where is output voltage is there? Suppose if you have to take here So wherever the diode positive is there, no, there you have to take this output voltage. Output voltage also how much it is getting? 0.1. You able to get the 0.1, right? 0.1 it is coming 0.1 and milliammeter current is 0. Now you are able to take, suppose I am applying 0.3, I am applying 0.2, you have to apply 0.2, 0.2 you have to apply, right? 0.2 you have to apply, 0.2. Now you able to see the output voltage, how much output voltage you are getting. So you are getting the output voltage. Another patch card I have to take because that one is not properly not working, right? You have to see that that is 0. Almost approximately 0.15 it is coming. For second 0.2 we are getting 0.16. This output current is equal to 0. Again you have to take which one you have to input voltage you have to apply. 0.3 you have to apply the input voltage, that is the 0.33. 0.3 you have to apply. You are able to see the output voltage and output current. Output voltage and output current you are able to see. 0.30 is coming, 0.3, 0.30, that output current also you are getting the 0. Now you have to apply the, again you have to apply 0.4 you have to apply, 0.4, yeah. So after 0.7 it is coming because it is a silicon diode, maybe you have to see. Now I am applying 0.7 you have to say, 0.7 and so on you have to see. Suppose 0.7, now you able to see the output voltage. Output voltage you are getting the value, how much output voltage you are getting the value. So 0.26 is coming and this output voltage is not properly functioning, right? 0.47 here current is displaying, that is 0.3. Suppose if you have to increase, maybe input voltage 1 volts you have to keep, 1 volts you have to keep, 1.5. So automatically you will get the output current, you are getting the more number of output current, you able to get it. Output current, sorry, this one is, yeah, you are getting the output current. So 0.5, right? So 12.1 milliamps you are getting. So take these values and you draw the graph. What is that graph you able to see? For germanium diode 0.3 volts is there. For silicon diode 0.7 volts is there. After taking this graph, the graph will come like this. Find the slope. So once you have to find the slope is equal to, you are getting the value delta I is divided by delta V. So now you find the reverse bias resistance is equal to delta V by delta I, which is equal to 1 by slope. Similarly, in the reverse bias, what we have to do? In the reverse bias, this diode negative you have to apply to the positive and positive you have to connect it to the negative. Negative you have to apply to the positive and positive you have to connect it to the negative, and then you have to take the readings, same way you have to apply the readings. So there how we have to apply, here you have to apply the first you have to apply 1 volts you have to apply here 0.5 and 1 volt you have to apply, the serial number 1, input voltage is 1. Now you are able to see the output voltage also 1, the output current is not getting here. Next you have to see the input voltage, you are able to take the 2, right? So input voltage 2 you have to apply, right? So then output voltage and output current you are able to see, the second one 2. So we are getting the 2, so output current is equal to 0. In terms of the micro you have to take. So micro, there is a current is coming 2.8. So now you able to take, you have to apply here input voltage. Maybe you extend this, maybe the breakdown it will come. When it will be breakdown, it will come, you have to see here. So while I am increasing, so this one also increasing, right. So at particular voltage is, it is a breakdown. So at particular voltage means around 14. So it is completely out of the order, it will going up. Otherwise you have to take here. So this going to the out of order, such type of out of order of the reading it will come. That is the breakdown of what? Breakdown of GNR diode. Clear? So junction diode, sorry. Now you able to take the graph. So what is that graph? You have to see. The graph will come like this. Wherever the sharp down it will come for a particular voltage, sharply current falls of such type of voltage we call it as a avalanche breakdown voltage. Which voltage it is? This is a avalanche breakdown voltage. Around greater than 6 volts this avalanche breakdown will come for the junction diode. If it is already we discussed this one, for the 0.7 volts are coming, this is the barrier potential voltage or knee voltage or built-in voltage. Forward resistance you able to find out from the graph, and the reverse resistance also you able to find out from the graph. This is the procedure to find out the VI characteristics of a junction diode and determine the cut-in voltage, forward resistance and reverse resistance from the graph of VI characteristics of the forward bias and the reverse bias. In the x-axis you have to take it as a voltage, in y-axis you have to take it as a current. Wherever we are applying, that applying voltage you have to take it as a x-axis. Wherever you are getting obtaining, that obtaining value you have to take in a y-axis you have to take. So this is the procedure to find out the VI characteristics of a junction diode. So please share and subscribe our YouTube channel. Thank you.